Everything around us is a representation of physics. Even simple moments can be explained by it, from how high a grasshopper can jump to how much work you can do with pushing a wall. The motion of an aircraft through the air can be explained and described by physical principles discovered over 300 years ago by Sir Isaac Newton. Newton worked in many areas of mathematics and physics. He developed the theories of gravitation in 1666 when he was only 23 years old. Some 20 years later, in 1686, he presented his three laws of motion in the Principia Mathematica Philosophiae Naturalis. The laws are shown in this video.
Oh, you're talking to me? Oh, this is for something in a presentation tomorrow. Oh, sure, I don't mind. All I'm doing can be applied to all three laws of motion by Sir Isaac Newton. Well, as you can see, the table is not moving right now, and it will remain so unless I move it. We all know that acceleration is directly proportional to the net force, while it is inversely proportional to mass. Therefore, the bigger the mass of the object is, which is something that this table is, the more force I have to apply to be able to push it faster. If this was light, it would have been easier to push the table. Well, as I push the table, of course I exert force to it. But then, the table also exerts an equal amount of force back at me. You're welcome. Bye.
Work and energy are quite intertwined with one another. Energy, as physics would explain it, is the ability to do work. Work, on the other hand, is a measure of energy transfer that occurs when an object is moved over a distance by an external force.
Hi.
Go.
Well, there are two basic forms of energy, potential and kinetic energy. Focus on this ball. Currently, it isn't bouncing as I hold it in my hand. Apparently, things at rest still have energy called potential energy. And now I've bounced the ball, I've released it. Energy of movement is called kinetic energy, and it is now something this ball possesses. The thing about energy is that it is never created nor destroyed, but it does not change or transform to a different version.
I thought you made it obvious earlier. I'm already pushing the wall.
What they meant is that you're not really going anywhere, no matter how hard you push the wall.
And why would you say that?
Well, sure you're exerting force, but the wall isn't moving, so you're not going to get any work done.
Oh.
Yes, that's right.
Oh.
Joseph and I are meeting to discuss first for our project in chemistry. Well, I was already at their place and I remember that I forgot to bring our project outline. So I went home and now I'm walking to Joseph's place. Bye!
It's been 172,800 seconds since I last slept, and I can taste death in my mouth.
How many pizza sticks does it take to get from Old Town to High Tech High on the 28 bus? In order to convert gasoline to pizza sticks, we have to make some assumptions. First, traffic has no effect on the gas mileage of the bus. Second, there is no variance in the fuel efficiency of the bus. Third, the distance from Old Town to High Tech High is 2 miles. Fourth, the average bus travels at 9.5 miles per gallon. 0.0000286 gallons of diesel fuel equals 1 calorie. And lastly, there are 320 calories in one pizza stick. In order to calculate the conversion, we start with the distance from Old Town to High Tech High, which is 2 miles. Next, we multiply the distance by fuel efficiency. 2 miles times 9.5 miles over gallons equals 19 gallons of fuel. Then, we multiply gallons of fuel by calories, which is 19 gallons times 1 calorie over 0.0000286 gallons. And lastly, we multiply calories by pizza sticks. 664,335.6 calories times 1 pizza stick over 320 calories equals 2,076 pizza sticks. In conclusion, it takes 2,076 pizza sticks to fuel the 28 for its 2-mile travel from Old Town to High Tech High. That's enough to feed the average person for 277 days.
Hi, here is a 2 minutes video to understand parabolic motion or projectile motion. We see a player throwing a basketball brilliantly and scoring a basket. Initially, he applies a force at an angle, and that force propels the ball, and after that, the ball follows a parabolic path. After falling through the basket, of course, the ball will bounce up and down till it comes to rest. So the initial force applied by the player is shown by the red arrow acting at an angle. That causes an initial velocity vector, yellow arrow at an angle. Now, after the ball is released, the player is no longer applying any force, and the only force on the ball is its weight towards the center of the earth. That's F is equal to mg. That means the only acceleration on that ball in flight is g downwards. You can see that there is no acceleration on the ball in the horizontal direction. So we resolve the yellow arrow in 2 directions. At the top of the flight, the ball has reached its maximum height, and there is no vertical velocity. There's only a horizontal velocity. Now, as the ball nears the basket, you can see the yellow arrow pointing downwards. So the resultant velocity is towards the basket. Now, if we draw that in the graph form, you can see that the horizontal velocity is shown by white arrows. They are constant. And therefore, the ax, the acceleration in the x direction is 0. And you can apply the equation v is equal to u plus at. In the vertical direction, the initial velocity is upwards as shown by the white arrows, and then the velocity becomes downward. And then you can apply the acceleration as minus g, since it's always getting pulled down by gravity, apply the normal equations of motion, and you can solve any problem on projectile motion. I hope this was useful. Thanks and have a great day.